Part 3, Central Nervous System, the brain, and we were just speaking of the gyrus and the sulcus, and where's the gray matter, and how much of this is present at birth and how much we have to grow in the first 5 years of life. So you want your child to feel safe to explore, give them a lot of hugs between the age of birth and 5 years of age. Do not hold back on the hugs. Make them feel safe enough to explore, because they're going to have a rich and safe environment in which to explore and grow all of the circuitry that is only 1/3 present at birth, and it goes through pretty much to completion by age 5. Notice that we have something here that's called a sulcus when we have an invagination, like this, in order to have all the folds, everybody fits together. When there is a difference between the end of one of the lobes and the beginning of another lobe, where they meet up, we have a very deep invagination called a fissure. So we have to understand that this, in fact, is not a sulcus. The artist got it wrong. They actually gave this as the example. Here they called it a fissure, and over here they called it a sulcus. Okay, so it is in fact a fissure. They got it right in this part of the diagram, so that's always good. Okay, now we do have a sulcus dividing the frontal and the parietal lobe. It isn't always clearly seen when we take a look at a real brain. Okay, see if you can take a look over here and figure out where is the central sulcus. Okay, sometimes you're not able to really pick it out perfectly. I think they might have figured out something here and picked a brain that looked pretty good. Okay, so we do also have here what's referred to as the lateral fissure. Okay, so we do have that separation. Now, it's important to note that we have, next to that central sulcus and right in front of it, we have the precentral gyrus. This is the primary motor gyrus. And then next to it is all of the memories. We call it the association area. Next to that, we're going to be having some visual voluntary control areas of the brain. Over here we have the post-central sulcus, in which we actually have somatosensory, conscious touch of the body and position of the body. Okay, so touch and proprioception. And then next to it, we're going to be having an association area with memories, okay, which we associate. Now, a lot of these motor skills and the way we touch things can go together, right? So there's probably a lot of association fibers connecting up these areas. So if you play an instrument, sometimes you can just move your fingers across the instrument, whether it's a piano, a guitar, or a wind instrument, and you can feel with your fingers where you're supposed to be to get a certain sound. And so even sound over here in the temporal lobe is associated with touch and with the motor movements of the body. Okay, so that's a really interesting little detail. Back here, we have the occipital lobe, which has primary visual cortex. So let's go to those pictures. There was a, how shall I say, a doctor named Dr. Brodman in the 1900s, as it were, between 1900 and 1910. The good Dr. Brodman performed many surgeries, and he basically removed the top of the brain of various young men, usually who had returned from war at that particular time. You can look up in history books what the heck war was going on in the late 1800s, early 1900s. But these American soldiers would come back from war. At that particular time, the armed forces in the United States was mostly made out of young men who were of the Northern European persuasion. They were probably from the British Isles, someplace, or nearby. They were probably German, English, French, and not a whole lot else. And they were right-handed, and they were mostly 90%. And so the Brodman's areas were developed by Dr. Brodman on a very, how shall I say, limited number of participants, mostly Northern European right-handed males. And so if there was a deficit, he would discover, oh, that's where that is. Okay, so he discovered lots of things going on in the brain, but I would submit to you that a certain degree of what he found was only unique to those people and not to the general world population, or even the same gender population, the, how shall I say, the cohort of females that would equate to the female population of the males he was working with. So, for instance, it was discovered that language is, in those particular males, Northern European right-handed males, whereas on the left side of the brain in this area called Wernicke's area. And so the ability to speak and understand language, speaking language is over here in this general area, having to do with, it's called Broca's area, and it has to do with the motor skills regarding sound and language. And then we have the sound and language understanding over here in this sort of overlay of temporal and parietal lobe. But in the female cohort, it turned out that language, especially its understanding and expression, was more globally arranged in the brain. So women have a much larger portion of the brain on average devoted to language, and not limited to very tiny small area in a lateralized situation on the left side of the brain. So I wanted to bring that to your attention because we're going to take a look at Brodman's areas now, these defined areas. Since the time of Brodman, we don't often talk about the numbering so much anymore. So all of these areas were numbered with Brodman's numbers. Okay, so now we just identify the area, and it's subject to more recent research, more exacting research. So here you can see the visual association area. This used to be Brodman 17. 19 was the association area. Okay, so there's things that you remember. You remember what a rose looks like. You remember what your family member's face looks like, what your mother's face looks like. You remember many things that you've seen, right? And so a significant amount of our brain, how shall I say, area, cortical area, is devoted to visualization. Okay, this part is devoted specifically over here to sensation and over here to motor skills. And so we have laid out over here, keeping the same color, the blue color here for primary somatosensory cortex is the postcentral gyrus, okay, is over here, and that's this area here, postcentral. Precentral is represented here. These are referred to as a homunculus, each of these. The word here is homunculus. And so the idea here is that we have various amounts of cortical circuitry devoted. See how much of the face is devoted here to facial expression. How much is the hand devoted? These are motor skills. Not a lot of motor skills at the elbow or the shoulder or the back. We don't do a whole lot with that part of the body. We do a significant amount with feet, hands, face, tongue, lots of stuff going on. Notice that the feet are hanging down here in the fissure between. Then you'll notice that over here, this is sensation, okay, rather than motor. and we can feel, we have actually more feeling with our feet than we do motor activity with our feet. Genitals are well represented, not overly. In terms of the head itself, generally the head is not significantly represented outside of the face itself. The hands have a lot of sensory sensation. The gut, you know when you're full and satisfied, etc. You know how things feel in your mouth, crunchy cookies versus soft cookies, etc. We'll come back to this in the next section.